All right, we are ready with a solidified gel that we can now run those PCR products. They have been taken out of the thermocycler. So you can see that that gel is a little bit hazy or opaque, which suggests it is not polymerized. It is also going to be hard to the touch. Again, this contains ethidium bromide, which is a carcinogen. So anytime you're working with Agarose gel electrophoresis, you'll want to make sure that you're wearing gloves as I'm putting on right now. Okay, so I'm going to take out the comb. And you can do this before or after you take the gel out. I use both hands on either side and pull it just straight on up. And then I'm going to wiggle this gel out of the caster and then turn this so that it's now in the buffer. And then pour some more buffer, 1x TEAE, on top. And we do use the same buffer both in the gel and in the chamber that the gel is in. That's important in order to have the same, essentially the same salts and pH that are running through the gel and conducting that electricity through the gel. So now we can load our sample. I have our tubes here from PCR in our ice bucket, and I also have some tubes that I'm going to pipette those samples into and mix up the loading dye with them. I've already added some water to the tube just to have a little bit more volume to work with. And now I'm going to add this purple loading dye. Purple loading dye has, it's a, you can maybe see as it's focusing, a 6x solution, not really. It is 6x in that it does need to be diluted to 1x, so we're gonna do that. This loading dye is used because it does have dye that's gonna be seen in the gel because DNA is clear, so we wouldn't be able to see it otherwise as it moves through the gel, so we have an idea of how far that DNA has progressed through the gel. In addition, it has glycerol in it, and that will help weigh down our DNA sample so that it can easily fall into the well that we pipetted into. So I'm going to add some loading dye to those tubes with water. And I am not changing pipette tips because I'm not so worried about being sterile here. Okay, so you have that dye in all of our tubes. And now we just need to add the sample to it. I did repeat this experiment twice with a little bit different conditions. So I will be running each of those samples twice. So 5 microliters of sample is what we will load so that we can see it clearly on the gel. And again, know what you're loading into each of those tubes so that you don't lose track. So it's always good to sort of label the tubes ahead of time and maybe even have a cheat sheet written down on your paper so we know what is what. And then last 2. All right, so the samples are now ready to load. I have them in those little PCR tubes again. Let me show you what they look like. And they need to be spun down for a second, so I'm actually gonna vortex it quickly to mix it up. And then spin it in a little centrifuge that I have here. All right, so we have our samples spun down and, oops, ready to be loaded, okay? You can see that they are purple. So I am going to, we do have to load a ladder, so I'm gonna skip the first lane and start loading this in. So I'm gonna put the pipette tip just over the well, and that sample will just fall right into the well. And hopefully you can see that there's a little bit of purple in this well right there. All right, that's sample 1, sample 2, sample 3, and then last one, and then I will do the ladder. quite all of it. There we go. All right. So those are all loaded. Now I want to do the ladder. This ladder, it depends on what sample that you're using, that you might want to consider different types of ladders. So this DNA ladder is going to be used as a reference. It again just looks like a bluish purple color because it has that dye in it. This is one that's called Quick Load 100 base pair DNA ladder from New England Biolabs. And I will provide the ladder to you so that you can see this as a reference. So these contain DNA fragments of known lengths that can be used as comparisons to our sample. So I'm going to load that ladder in there, and everything is where it needs to be. So now consider the charge of DNA. DNA being negatively charged means that we would want to run that DNA towards the positive electrode over here. So you can see that I have the wells on the opposite side. So they're going to move in this direction. We have this hooked up to, oh, sorry, that's a terrible sound. I have this hooked up to a power supply. So I'm going to turn this power supply to a higher voltage. About 120 for this device is fine. This does depend on the equipment that you're using. And I'm going to go ahead and press start. And what you may or may not be able to see, and I'm going to try to move this down here, is that bubbles start to form. So hopefully if you look closely, you can see these little bubbles forming. Those bubbles are a good sign that we have electricity flowing. And now we just wait. So we wait about 30 to 40 minutes. It's good to check the place of that dye front as it moves through the gel. So you can see things at the top. You can see where those wells are. That's where our dye is. So we'll come back later to see that dye moving through the gel, moving towards that positive electrode, and then image the gel under a UV transilluminator.